My name is Talfan Barnie, and I'm a remote sensing specialist at the Icelandic Met Office, and today I'm going to show you how we measure plume heights from web camera images. Okay, so now that we have the gas fluxes from a DOAS traverse, we now need to know the altitude at which the plume was in the atmosphere for input into the dispersion models. And in order to do this, we make use of a network of calibrated web cameras that the Icelandic Meteorological Office maintains across the country. By calibrated, we mean that we know where the camera is spatially, we know its orientation, so the direction in which it's looking, and we also know the interior geometry of the camera, so we know the focal length, we know how the lens is distorting light as it's entering the camera. And a website has been set up for measuring these plume heights from these web camera images. Unfortunately, it's not available to the public at present, but hopefully it will be in the near future. And now I'm just going to walk you through this website, which has been developed to make this process kind of hopefully intuitive and easier. There's a drop-down box in the top left corner which allows you to select the cameras that IMO has that's currently looking at the eruption on Reykjanes. You can see it's a very, very cloudy day today, but fortunately there is an archive, and so we can go back in time and we can find some good examples. And so I've selected this example from the 3rd of July, early in the morning, and you can see the plume here is nicely silhouetted against the sky. It's rising up from the vent and then reaching neutral buoyancy and then drifting off in this direction down here. And so as I said, these are calibrated web cameras. And what this means is that we know the geometry of the camera such that we can take points in geographic space. We can take a point with a latitude and a longitude and a height, and we can project it onto the image. And so we can get a sense of where things out there in the world would appear on the image that the camera takes. Now, in order to measure the height of a plume from a web camera image, we need to do this in reverse. So we need to go from a point on the image to a point in three-dimensional space. So we're going from 2 numbers to 3 numbers, basically. And this is an underdetermined problem, and so we need to make some assumptions about the geometry of the plume in order to make this work. And the 2 assumptions that we make are the location of the vent, the location of the source of a plume, and we also make an assumption about the direction that the plume is traveling in. So if we look on the map here, there's a little yellow blob, and as I drag that, the vertical yellow line on the image is moving around. And this is the location of the vent. So what we're saying here is that the yellow blob on the map is the location of the vent, the yellow line on the image is the vertical line immediately above the vent. And the cyan line is the direction we're assuming the plume is going in. And this is the direction that's taken from, the wind direction that's taken either from meteorological numerical weather prediction models, or it comes from met stations. And so the idea here is that you can drag the vent location over where we think the eruption is happening, and we can then adjust the height at which we plot the cyan line. And as we adjust the height, you can see that it's rotating, and that's because the website is automatically taking the direction, the wind direction at that altitude above the vent. And so then it's simply a matter of adjusting the height until the cyan line is at the level that you want to look at in the plume. So here we're looking at the top of the plume, and we can see we're getting a height of around 1.3 kilometers. Then we can then save the plume heights like this, and we can see here that in this graph at the bottom, it saved these plume heights from this image and also from other dates and times. And so the plume heights then appear in this text box in the bottom left-hand corner of the website in an appropriate format to be cut and paste into the dispersal model. So in summary, we need estimates of the height of the plume to input into the dispersion model. We also have a network of calibrated web cameras of known geometry, so we can relate coordinates in geographic space to image space for making these estimates. And we've come up with a simple website which allows people to kind of interact with the images and to make these estimates.